What was it again? Israel, yeah. Yep, same channel. Okay, how's it going, man? That's perfect.
Welcome back, folks. Welcome to web software development, architecture, something like that. One. All right. It's been a whole week since fall break ended. It sure feels like we need another one, right? Yeah, well, the bad news. It ain't coming for a while. Okay. But before we get started talking about, so we've spent the last, I don't know, whole semester, I think, basically explaining how to make web applications. And now we're going to sort of softly transition to how to actually deploy those web applications out there where people can use them. So we're going to start by talking about user identity. Probably you want users to log in. You know, I will say for like really small applications, maybe you don't. You know, if you build an application for just you and a couple of friends to use, like a pretty good identity mechanism is just like tell everyone not to mess it up. And if they do, stop being their friend, you know? Easy method, easy method. But once you deploy your application out to users who maybe don't know you, or much, much worse, users who are paying you, then you probably do need to start thinking about, you know, what about bad users? How do you keep them from breaking your website? So we're going to talk about identity and permissions and authentication this week. Next week, we're going to talk about security, sort of beyond just setting up security policies. And then from there, we'll slowly transition to talking about deploying this on the cloud. Yes, sir. Close the slides. Yes, yes, excellent. All right. You can see I've got all my assistants right here. You didn't sign up for it, but it's like 15 seconds of service per class period. Yes, let me upload the slides. As I'm doing that, to sort of distract / confuse myself, I would want to make a small announcement. You see, this class happens very late in the evening on Wednesday. And this is fall semester. So one of our classes will be the day right before Thanksgiving at super late. Hilariously, this is the main topic that I got comments on in last year's student eval. So this year we're going to cancel the lecture. That's like late in the evening, immediately before Thanksgiving. Yeah, I was just looking. All right, that was a little silly, folks, but okay. You know, I will say it's a funny thing, right? The truth is you all pay quite a bit of money to be here, but students are never upset when I cancel a lecture. I'll tell you that. Yeah. Well, the truth is that's a big difficult thing in life, you know. The thing you should do, the thing you thought you wanted to do a month ago, is often not the thing you want to do right now. All right. So I'm going to cancel that lecture. I was just looking at my schedule and I was like, oh, I got a free slot. What should I fill it with? And then I thought, maybe Thanksgiving. Yes.
Just real quick, any news on the midterm, like when the grades will be out?
Hopefully tomorrow. Yeah, apologies that it took longer than expected. I messed up and failed to assign one of the questions to any of the TAs to grade. So they dutifully graded everything except that one question, and then I caught that and they're going to grade. So apologies, that's on me. Your TAs did a great job. But if you tell them not to do something, you know, like they're busy people, you know. All right, any other questions about class admin stuff? I'll also note there is no homework. There's no homework due on Thanksgiving or like Thanksgiving weekend. It's an in-between homework assignment. I
Oh,
believe if
right.
we check. All right, yeah, I mean, call me on it. Yeah, okay. Well, okay, yeah, this homework won't have a separate, the phase one for this homework is it takes like 15 minutes. Just don't do it that weekend, do it any other time, you will be. In general, the last homework is, I don't know if I want to say somewhat easier. It relies on you carefully following exhaustive instructions that I provided. Empirically, it seems pretty hard as a homework assignment, but not like conceptually, just because reading is challenging. Yes.
When are we gonna need the, you mentioned of the entire domain?
Yeah, that's going to be for this last homework assignment. In fact, that is what this phase one that's due the Friday of Thanksgiving weekend is. It's purchase a domain, any domain. If you already own a domain, you're way ahead. You do not have to purchase a domain if you already own one and are okay redirecting it to a website for class.
Speaking of, any chance we would be allowed to use like something dot website I already own dot whatever?
Yeah, that's fine. That's fine. What I really want you to do,
No,
what I really want you to do for that homework assignment is to set up, like, the main thing I want you to do is set up DNS.
oh,
So if you already own a domain, yeah, we'll talk about that when we get to it. We don't, this is November.
okay.
I've never seen students thinking this far forward. Come on, people.
It's exciting to get there.
Yeah, it'll be fun. If you don't own a domain, which is the normal situation for most of you, then you'll buy one at that point. Okay, if there's no more administrative stuff, let's talk about our actual topic for today, which is user identity. It's also going to be our little intro to security. And I want to start not actually by talking directly about security, but not directly about user identity. I want to talk about why security is sort of a different kind of topic or a different kind of thinking than a lot of the programming that you're used to. Okay, because usually when we're programming, we think that there's kind of mistakes that we might make, and we should avoid making them, and then we need to find them and fix them when we do, right? So like you have a typo, and it might cause you to exit the wrong field of some object, and that's might cause something to crash. Okay, and we don't want our program to crash, obviously, and we don't want our service to go down or whatever if something bad happens. And then, this is a kind of correctness property. It's easy to think that security is like this too, that security is just like a list of bad things you want to avoid. The problem is, in reality, almost all of you, probably all of you, but if you truly believe that you stand aside, that's okay. Probably most of you make mistakes sometimes, right? And then you introduce bugs into your source code, and then you don't find out about them. Right. Now, okay, with a normal bug in a program, if a user hits the bug, they'll tell you because it didn't work, and then you'll fix the bug. Security bugs are not like this, because the people who might notice your security bug might have a vested interest in not telling you, and in fact doing bad things to you. Like stealing your users' data, or your money, or mining Bitcoin on your server. These are all popular things to do if you have security bugs. So it's easy to think of security bugs as kind of the same class of bug. It's not. Specifically, it ignores the attacker. In normal programming, the attacker is your own ignorance. And here's the good news. Your ignorance is a pretty dumb agent. It's just you making mistakes, not purposefully trying to mess up your program. But when we're talking about security, we have an attacker, and the attacker is evil, and they're very smart, and they also hate you. I mean, exactly who your attacker is, that's something important to think about, and we'll talk about that a bit later on. There's definitely attackers that are like way too powerful to defend against. So like, for example, if the FBI wants to hack into your computer, they can hire someone really smart to hack your computer. They can also arrest you, put you in jail, then say, we have a plea deal where you agree to run the service the way we want, or you're getting a felony and 30 years. And this isn't really a security vulnerability other than that you exist in physical space within the confines of these United States and like to eat and go outside and see your loved ones. These are vulnerabilities you are unlikely to defend yourself against. Yeah, your mom could probably make you do a lot of stuff to your website. Sure. But there's a lot of weaker attackers that we do want to defend against. Like in the grading application, a really natural attack we want to prevent is one student trying to change their own grade, or one student trying to change another's grade. Other weirder things like a TA trying to change a grade for a student they're in cahoots with, right? There are options. And it definitely is useful to defend against these weaker attackers. If you run anything on the internet that touches money, the broader criminal ecosystem is going to be something that you interact with and want to defend yourself against. So there's almost always an attacker you want to think of when you're talking about security. The attacker isn't just your own mistakes or your ability to fat finger some code. It's actually an attacker out there specifically finding vulnerabilities, not telling you about them, then using them to do bad stuff. Okay. The second thing is attackers get to choose how they attack the program. You can't think of this in terms of like, well, I'll fix a bug when I find it, because you have no reason to think you're going to find it before the attacker does. And if the attacker does, they're going to try to keep quiet. They're going to try not to crash your program. They're going to try not to produce log entries or show weird effects for other users on your system. And they might even take further steps to hide their access to your computer, right? So they might gain access to your server through a software bug, use that access to install some kind of like command and control system by which they can affect your server without showing up as like a logged in user. Using something like so again, the attacker has agency. They get to choose how they attack your program, and they're going to choose the way that's least convenient for you, the bug fixer. So again, a bug fixing mentality doesn't work because you might not find out about the bug. And then finally, often when we think about like a bug in our program, we think about like the program crashes. And program crashes are bad. But it happens. People make mistakes. The issue is that there are things your program does, or often data it has access to, that's way more valuable than the ordinary program crash. So even if you think about something fairly simple, like a student's grade, you got to think about, well, could you cause a student by changing their grade to, for example, fail to graduate? That'd be really bad to that one student. Probably much worse than any program crash you personally have been responsible for. And it's maybe not fully your fault, right? There's an attacker, but you should try to write software that can't be attacked easily by others. So when you're putting software out on the internet, it's useful to people. A variety of people use it. Some of those people are more important than others, or use it for more important tasks than others, or have more riding on the program than others. And the security vulnerabilities are a way for those users to get hurt for using your software. You probably don't want that. So the upshot of all of this is that when we think about security, we can't start from what are the bugs. We got to start with what are we trying to guarantee? This is called a security policy. It's a question of what the security properties you're trying to enforce in your program are. And the reason you want to write this down ahead of time is you want to know what kind of bugs are you on the lookout for? What should you be enforcing? What actions are restricted? What actions could harm other users? What kind of user permissions or privileges do you need to be checking for? Because again, if you don't write down this policy, look, you can do this for programming too. Write down a specification for what your software should do and think really hard about that. But people typically don't do this. You discover this over time as users interact with your software, tell you about things they like to work or things that don't. And this is totally fine for ordinary programming, but it's not a good fix for security. Again, because there's an attacker, because the attacker has agency, because the attacker is trying to make things harder for you, not happy. They're going to not raise alarms, not file bug reports. They're just going to quietly do evil stuff to your users. So that's what we want to do when we're thinking about security. We want to start from a security policy. And a security policy describes who are all the users and what actions might they take and which users should be allowed to do which action. And action here is inclusive of viewing certain things. So unlike most other parts of the program, you need to design security up front. you need to think through as exhaustive as possible a list of all the actions and data that people can see and which users are allowed to do which ones. And then that security policy you wrote down, that's kind of a roadmap. Every time you write any code that does anything, you got to make sure where is the security policy being enforced? What parts of the security policy are involved in whatever code I'm writing? And then what checks do I need to do? So here's like a really simple example. Okay, in the grading application that y'all are using, we've got assignments and we've got submissions. So here what I've done is I've organized my security policy, security police. Security police. Oh, wow. Here I've organized my security policy by the two kinds of objects in my database. And this is very safe because, recall, all of the state of your application lives in the database. So organizing it by all the stuff in the database is good because other than the stuff in the database, there's pretty much nothing here. So I looked at assignments, and for each one, I'm thinking who can view them and what kind of changes can be made. So for assignments, it's pretty easy. I said assignments are public, it doesn't matter who sees them. I think in homework, what are you on, 5? Yeah, in homework 5, you end up requiring login for the assignments page. But I'm not even choosing to require that in my security policy. Assignments are public. And no one should be allowed to change them except the professor, who's also the super user, sort of the admin user who can kind of change them. So assignments are very simple. Submissions are a little bit more complicated. Here I've got the rules. A student should only be able to see or submit their own submissions, and they should only be able to view their own grades. And then TAs also have a complicated relationship. They should only be able to see or grade submissions that are assigned to that TA. Now again, this is something I made up as the owner or designer of this application. Right, you can imagine why you might do this. So like, for example, it's sometimes the case that a professor has their own like brother or daughter or other relative in the class. And then maybe it's really important to enforce this kind of, or like one TA has like their brother in the class. So maybe it's really important to enforce this property so that you can't go and change your sibling, right? You can imagine a different design. You can imagine making the TAs fully trusted. Then the TAs can view every submission. Gradescope, for example, works like this. By default, all TAs have access to all of those submissions. When we write down this security policy, and again, note what it lists. It lists every object in the database. It lists all the actions that can be taken to those objects. And then it describes which users are able to perform those actions. And this is the goal we're trying to reach. And then as we go through the application, we're going to enforce this by adding various things. So more abstractly, security policies are organized around two concepts. First, who are the users of your applications? And then second, what's the data and what actions can be performed on it? So we ask which users can see any particular object and which users can do which kind of modifications to each particular object. And this idea that we've got users and then either objects or actions, that gives us the kind of core way that we in computer science think about security. We think about it as having two key pieces: authentication, namely figure out who the user is, and authorization, namely figure out if they're allowed to do a particular thing. So today we're going to talk about the authentication bit, and we'll talk about authorization on Wednesday. Okay, so let me pause here and ask for questions. Core idea: security, online functionality needs to be designed up front. And that's because you got an attacker. If you make any mistakes in the design, you expect the attacker to exploit. And design up front means write a security policy like this.
How many levels, or like what levels are going to put security on? Like the database, the actual like guts of the thing, the maybe the like the actual hosting end?
Yeah, so I mean, it really like, okay, at least one. Let's start there. Anything in your security policy should be enforced at least at some level, right? Like, let's start there. Once we get to the point that we're enforcing the security policy somewhere, then we can ask ourselves, we can refine the security model. So we could say, well, one thing that's not in the security policy right now is the role of the developer. Should we try to protect the database from a rogue developer? Maybe, right? Or maybe not. I mean, like, doing that will presumably cause a bunch of annoying bureaucracy about like enrolling people into various roles and giving them permission to do stuff. But in a big company, it's absolutely necessary, right? Like, if you think of a company like Google, which has, I think, like 150,000 employees, like, surely some of them are bad people. I don't know, like 150,000, that's a lot of people. That's like, what, a third the size of Salt Lake City? It's you know, some of them are gonna be bad people, some of them are gonna be spies. For sure. I mean, you don't think Google's a good target for spies? Definitely. Right? There's a fun story, like a few weeks ago about how apparently there's this new thing of North Koreans taking remote only jobs at tech companies to earn money for the North Korean government. I mean, I'm sure they're good people, but like, do you think the number of North Koreans working at Google is 0? Hopefully, but like 150,000, you gotta have a pretty good success rate to like literally never fit. So, you know, in a larger company, you're gonna have multiple levels of protection, and multiple will be like lots of lots, right? In a smaller application, you're gonna trust a lot more people, like all the developers, you'll probably trust like everyone who like runs the data center your thing is hosted in, because you probably will rent the data center from someone. So like, I don't know, what are you supposed to do? Whereas like at an extreme end, like a Google scale, like if Google owns a data center, should it be worried about like an armed attack on the data center? Plausibly. Because like, I don't know, Google hosts a lot of valuable data. Amazon runs data centers where the entire data center is classified top secret. I like assume they've got some good security, like physical security around it. So, you know, what exactly your security policy says, how detailed it is, how many parts of your system it covers, that's going to depend on like what makes sense for you, right? This super small security policy for our grades website is definitely like kind of the minimal thing I could put together and still call it a security policy. But you know, for an application used by a couple dozen people, this might be sufficient. Whereas if you think about like very big applications, very important ones, anything that touches money, then you're going to want to be a lot more careful. Other questions? Cool. All right, so security policies. The other thing that you're considering or you're coming up with security policies is what are the capabilities of your attacker? So here in my security policy, what is the attacker actually able to do? What could the attacker do to see or submit something that you're not allowed to submit? So this is the other thing you're thinking about. How much needs to be in your security model? This is kind of the answer to your question. So like one possibility is they're internet connected devices that send you HTTP requests. And that's pretty much where we'll end it, like in this class. And that might cover, other people in your computer science class want to mess with you. That might cover, like online criminals, but not like international mafia organizations, just like people trying to steal money on the internet. But it doesn't cover, very, very sophisticated capabilities, right? Like, nation state intelligence services, which have capabilities like, I don't know, there was a Bloomberg story 2 years ago that claimed that Supermicro servers sold to Google contained a secret computer chip inserted by Chinese intelligence. Now, Google denies it, and Bloomberg stands by their reporting, and no one knows what happened. But it's like definitely within the capabilities of a nation state to like secretly make circuitry and, like convince some semiconductor manufacturer to produce it. So, the threat model is important to consider because it tells you what is in your security policy and what you're just like, you just trust it. Right, so in this class, anything you do, you're gonna trust the CPU that you bought because I don't know, what are your options? But of course, if you are actually like a nation state intelligence agency, you would not. I believe the Chinese government issued a law 2 years ago saying that Chinese companies are not allowed to buy Intel chips anymore. Chinese state-owned entities should not buy Intel chips anymore. And you can understand what they're thinking. So in this class, though, we're going to talk about fairly unsophisticated attackers. We're going to be talking about attackers who are making HTTP requests to your website. They probably don't have any privileged access to you, like the police would have, or your web hosting provider, the way a nation state, like the nation state you live in would have, or like crazy sophisticated technology. They probably wouldn't have deep knowledge of like libraries that you use. We're going to trust those. We're going to assume they don't know of any like cryptographic breakthroughs that aren't public knowledge. So we're just going to be talking about fairly unsophisticated attackers, because if we can't stop those, then like no point talking about the more sophisticated ones. Do you have a question? No. Okay, cool. Sometimes people like scratch their nose when they don't have a question. Okay, cool. So yeah, a lot of stuff that is probably outside your field. Okay, so now let's move on from talking about threat models in the abstract to talking about how we can actually sort of make progress against these threats. And the place to start is authentication. So it's very confusing. There's two terms, authentication and authorization. And I don't know of any good like mnemonics of how to remember them. Everyone calls the combination of these two things auth. So that part makes sense. But which is very confusing. So I'll try to clarify anytime I use the terms. Authentication is about figuring out who is making a certain request. Here's kind of the core problem. In the web, there is a client-server architecture. You know that there is a program called the server and another program called the browser. And they talk to each other over the internet. So when you go to a website like google.com, you've got software running on your computer, and you've got software running on Google's computers, and they talk to each other. And specifically, the client's job is to send requests, and the server's job is to respond to those requests. So we've talked about GET requests and POST requests. That's what I'm talking about. Now, specifically, here's the key part. The server does not have a particularly clear idea of who it is talking to. The server receives requests, and it has the option to reply. But when it receives the requests, it does not like see you, your face. It doesn't know your name. It knows stuff like your IP address, which doesn't really reveal that much information. At the very least, it can be kind of faked. It knows various other information, but only information from your browser that's in the request, which presumably a bad browser could lie about. So the server doesn't have a clear idea of who the client is. But then on the other hand, the clients don't necessarily trust the server. Potentially, you don't want the server to know your real name. Because then, I don't know, you want to do bad stuff or start abuse on Twitter or something, right? So we've got this problem that neither side particularly trusts the other, and there's no clear way to tie identity to like a specific user or a specific computer, etc. So the actual way this works on the internet is pretty clever, and it works kind of the same way that like the government works, right? So how does the government know who you are? Well, it's because you have a driver's license, typically in the US, right? Or an identity card or a passport. There's a couple of other options. So why? Well, we know the government can't just ask you who you are, because then you could lie, right? Like, you have taxes you didn't pay, government asks you who you are, you're like, oh, that's not me. I'm John Smith, I don't have any taxes to pay or something, right? So you can't use that. You don't want to use appearance. You can't really use like fingerprints or something, partly because it would just be very expensive to gather those from everyone, and also like a weird privacy violation that we probably wouldn't stand for. So the governments came up with a very clever idea. They give you a document called like a driver's license, an identity card, etc. They work really hard to make sure that only they can produce this document. In the olden days, this was literally a letter written by the king and signed by the king, which security wise is like not great. But these days, the government actually goes through quite a lot of effort to make sure the passport or driver's license can't be easily forged. Like, got my driver's license right here, and it's got some funky like holographic effect if you tilt it in the light, and I think that's like pretty expensive. And government's actually put a lot of effort into this kind of thing. Money works the same way, right? Government creates these dollars, these monies, and they make sure you can't duplicate it. And then, because only the government made it, and the government knows it gave it to you, then it assumes that if you have this document, it's still you. The reason I go through driver's licenses, which hopefully are intuitive, is because on the web, this actually works the same way. Every server on the web issues a unique identity to you, the user. That unique identity is called a cookie. No one knows why it is called a cookie. No one knows. People have tried to find it.
They give you a cookie.
They give you a cookie. That's right. Every web server, if it wants to track who people are, gives every client an identity document called a cookie. They use some kind of fancy cryptography to make it so that that document is unforgeable. And then anyone who has the cookie is presumed to be that user. Yes.
So do we know who like originally started calling them cookies? Like we have no idea where it just became a tree.
That's like the sort of place I would look this up. Yeah.
Magic.
Yeah, that's the original name. Cookie is cookie definitely derives from the term magic cookie, which was prominently used in the X Windows system. But like, yeah, no comments here on where it came from. Similarly, if you go to Wikipedia and type cookie, and it's important to go to the disambiguation page because we don't want the actual cookies. Computing, magic cookie, early use. Yeah, this is what the jargon file said too, that it came from the fseek in the C standard library, but like that doesn't necessarily help. Okay, like what made them? Yeah, on some systems it is a magic cookie. Clearly, this was intended to be a phrase people understood. I think it is, yeah, not super clear why they're called cookies.
Okay.
Yeah. So yeah, no one knows why it's called a cookie. But the point is, it's an identity document. Despite the bizarre name, it is an identity document issued to your computer in much the same way a government issues a driver's license to you. And then your computer can show the cookie to the server, and it knows that you're you. Yes.
So
It's more about the word cookie.
but legit though. No, but like you go on a website and it says that you can accept or reject all cookies. Does it mean it's giving you like a ton of identification documents or?
Yeah, that's a good question. That is a great question. If you go to a website, like I don't know, GitHub's a website, let's find out.
Sure is.
All right, so here we went to a website, okay? I've got, as in some web dev. I have a bunch of network requests open. These are all the network requests I issued when I loaded this page. I'm gonna go to the main HTML page. It's called readme.md, but it's an HTML file. That's the name of this page. And I click on cookies, and I got this many. And if you look at these in some detail, all right, some of these are clearly some kind of preferences, like time zone and preferred color mode and file tree expanded. That's something you could use cookies for, but it's not super security relevant.
Right.
Because it's not unforgeable by the user. It does say here .com user, but I hope GitHub does not use this in any meaningful security sense. And then we've got 4 at the top. It says hosts user session secret. I'm guessing. Oh, user site. Okay, host user session, same site. And then a device ID, and then a GitHub session, and then Octo. I assume this is also GitHub related because their logo, they call the little octopus, they call an Octocat. And then they have user session down here. So to me, it looks like I've got at least five identity documents
Really?
issued to my computer on the topic of this website. Now, GitHub is pretty good. Let's go to NewYorkTimes.com. Good to know, New York Times. Let's reload this page. It loads forever. And the reason I chose NewYorkTimes.com is because it's going to have lots. And the reason it's going to have lots is partly because it's got, I don't know, all kinds of weird stuff in here. Not super clear what exactly any of these mean. And then note that I'm actually going to make a lot of different web requests. So like fonts. So this font request looks to have no cookies. And then some JavaScript and some more random stuff. I don't know. It made dozens and dozens of requests, and some of these are going to be to different sites. So for example, this sign into the New York Times with Google might be a little odd that the New York Times suddenly knows who I am. But that's actually because this is a small part of a web page owned by Google. So in going to this website, I presented like 10 identity documents to New York Times, and then another couple to Google, and then some to various other services, especially ad companies. So every site on the internet is issuing its own identity documents to your computer. Probably more than one for bizarre reasons that don't make sense. And then your computer stores all of them and sends them out as it makes requests. Yes.
I think you just answered it. Just want to confirm these items are downloaded to the server. They're
That's right.
stored on the server side.
Yeah, in fact, if I open it up, you will see that there are request cookies. So these are the cookies your computer presented to the server. And there are response cookies, which is additional cookies issued to my browser by the server. These don't seem super interesting because probably I just refreshed the page and like I already had those. I wonder if where's the button to clear cookies? Okay, I'm not gonna go looking for it. There's a lot of buttons. Yes.
So if I have like a friend in New York and I'm on a website, and I send him the I have relevant identification cookies, and then he like throws that in like a GET request and sends it to the same website, does he get all the stuff?
He's logged in as you?
Got it.
Yeah, same as if you give your friend your ID card to do something bad. Then, yeah, assuming they look kind of similar, right? I know that actual driver's licenses have like photos on them and so on. But yeah, you could like pretend to be them. I don't know, like you hear stories about this, people like pretending to be someone else and, like stealing their money at a bank or something. Yeah.
So a lot of websites give you the option to accept the cookies or decline the cookies. If you decline them, do they then not have a way to identify you? It depends.
Yeah, okay. Do you want to accept cookies thing is a weird thing invented by the European Union. And they set the rules. And those rules are like all laws, super complicated and weird. There's like a distinction between essential cookies and non-essential cookies. I think law kind of dumb, American #1, but yeah, like what a website specifically will do if you say don't accept cookies is entirely up to the website. This isn't the browser feature. This is websites being nice to you.
Oh.
Like you go to some business establishment and they could tell you like, oh yeah, there's like cameras in the store, but we only store them for 2 weeks. But like they could tell you that, but this isn't like a technical limitation. They're just being nice to you.
My understanding is that it makes, especially living in the US, almost no difference what you click on the majority of those pop-ups. Because like you said, like.
Yeah, those pop-ups might also only do something in the European Union, like you don't really know. I would not rely on that to do anything.
So like IDs also have to be updated over time?
Yep.
Like, do you have to update cookies
Yeah.
over time too?
Yep, and we'll talk about that shortly. Okay, so this is the basic schema. Okay, the server knows who you are because it has issued an identity document to you. And then when you make a second request to the server, you show that identity document, the cookie, And the server says, oh, you're that same person who came earlier to do the other thing. So for example, you log into a website. Server issues you an identity. That identity cookie on the server side says, hey, this person is logged in as so-and-so user. Then you go to like your profile page. The server says, oh, hey, that identity document, let me look up the info. I know they're logged in. I can show them their profile. So that's how it works. We can actually demo this for our application here. Let me exit from this. And I think it updated Python. Gotta do that. So now if I go to localhost 3000, I have gone to localhost and let's see if we can delete these. I know what we'll do to delete these. This is kind of lame, but I'm just gonna run it on a different port that I've never run it on. All right. So I've gone to this. Already have. Already have the cookies. But I guess a different port. Why did they keep the cookie? Must be the browser doing something weird with localhost. Oh, yeah, no, this port's so much faster. Okay. Now I know what it is. All right, let's figure out how to clear cookies.
Could you just run it in incognito tab?
Yeah, that's right.
Or usually are.
Yes. You're right. Let's do
Whoa.
it. That's it. All right. Thank you all. I forgot about incognito mode, but shows what I know. All right. I actually need to create a new incognito window. Then I need to go to some random website, my website. And then I need to go open the network tab. So we will record the network requests. And then go to this website. And now you can see there is no cookie being sent at all. And actually, Django hasn't sent us a new cookie either because it errored out before it managed. So then we can go to the admin page. And now that I went to the admin, still no cookie being sent. But if I log in, I will now see the server asking me to remember 2 cookies. So upon logging in, the server has issued me these identity documents. You can see it parsed over here. There's 2 of them. One is called CSRF token and one is called session ID. You can ignore the CSRF token. We'll talk about that in a week. But the session ID is the main identity document that Django uses to know who I am. And we have this long session ID in the client. And then on the server side, just like the government has a database of all of the driver's licenses and who they're supposed to be issued to, Django also keeps the database of all the session IDs it's handed out and what it knows about that person. So let's could we just do this? Okay. So I've opened up the database that Django is storing all the data in. And you can see there's a bunch of these, but one interesting one is called Django session. So I'm just going to dump that one. And you can see there's a couple of different session identifiers, 1, 2, 3, 4. And if we go back to the browser, we can see this one starts with AHZ1T. And here is AHZ1T. So we can see that this information, this long string, this cookie, is stored both by my browser on behalf of me, the user, and also by the server so that it can identify different users who log in and what properties they have. Questions so far? Yes.
Would storing a cookie on the server for every single session not make it vulnerable to like DDoS?
Yeah, they deleted that for a while. That's actually why, if you look here, you will see. I don't know what's special about this time. It's near midnight. This is UTC time. It's right around midnight UTC time, which changes over at 7 p.m. So you can see that it's stored when it issued the cookie, and it's regularly going to go in and throw away old cookies.
Theoretically, be brute forceable.
I mean, the cookie is very long, so it would take a very long time, and specifically an exponentially long time.
Yeah.
So yeah, if you had some kind of trick, maybe you could, but on its own, no, I don't think so. Other questions about the cookie value? Yes.
Am I interpreting it correctly that it issued you that cookie next month on the 4th?
Oh, yeah. It looks like this is an expiration date, 2 weeks.
Okay.
2 weeks in the future. Yeah, probably it's not an issue date, it's an expiration date. Yeah, sorry. So you can actually see all the different browser sessions that I've logged into the server with. And this one is probably expired, and I don't know when exactly Django will decide to clean it. Probably never, because I only turn this on during class. But yeah, it looks like that's an expiration date. Yes.
So what's the second string?
Great question. For that, let's dig in a little bit on how this works internally. Okay, so the first bit of terminology I want you to know is the concept of a session. Okay, a session has a session ID, that's that cookie value we were looking at. The session itself, that represents a single device. So one user can have multiple sessions if you're logged into the same service for multiple devices. The reason we think about one device is we mean one browser, one specific person who is issued an identity document. So if I log into this same website from Chrome and from Safari, each of them will have their own cookie. The server will have no reason to think they're the same person because they won't have each other's cookies. They store the cookies separately. And then as a result, I'll have multiple sessions for a single user. So every time you go to a website from like a new computer, a new browser, an incognito mode session or something like that, that's going to be a brand new session. That's going to be issued a brand new session ID, and the server is going to keep track of all the sessions that it's issued and what it knows about those people. So here I said the server is going to assign you a session. It's going to make a brand new session if you show up without a cookie. And then you're going to have this session as you make additional requests to the server. And that same session will be reused because your browser will store that cookie and report it every time you make a request. And then the server also stores information that it wants to attach to you in this session. So on the server side, again, we've got users, which are like user accounts. And then we've got sessions, probably multiple per user. And then we've got individual requests, which the browser ties to a session because they have a session identifier. So this tree structure: users, sessions, requests. All right, so let's okay, I want to skip to this part. We'll get back to philosophical musings on cookies, which people have already asked me about. So yeah, so we've already seen that when you actually log in, Django is going to issue you a session ID. And this session ID cookie, that is your server granted identity, and your browser reports it every time you make an additional request. So let's see how this actually works. I'm going to, instead of just doing this in slideware, I'm going to go to the actual website code. So let's look, okay, we'll do it in incognito mode. So what I've opened up here is the Django project source code on GitHub. And one of the reasons I want to bring this up is to kind of remind you that this is source code that you can just read. It's not typically even that bad. So you can see here that we have something called an abstract base session. That's how you know it's the good stuff. It's an abstract base session. And you can see that it's defined as a Django model, much like the models that you've already been using throughout. You see that it has a model with 3 fields: session key, session data, and expire date. And that actually matches up with what we saw here: a session ID or session key an expire date, and then this thing in the middle. Oh boy, presumably that is the session data. So again, totally bog standard model that you could write yourself. You can see that the session key is stored in a car field. It's given a max length, and it's told that this is the primary ID for that field. You can see there's actually an index on the date time field, I assume, so that we could find out of date sessions and delete them. And then there is the session data as well. So this is what the Django is saving to and loading from the database. It's a totally normal model, and it works much the same any other model does. So you've got the session key that matches your cookie, and what the browser will do, what the server will do is when a web request comes in, it'll check the session ID cookie, use that to look up this abstract base session from the database, and then read the session data, which will tell the server what it knows about you specifically. Okay, and let's see where that happens. Yeah. So if we look at this data, I believe that's not how this works. No. I believe this is just base 64 encoded. Google's easier than man pages. Sure. So I think if you grab this data, a little better, not quite. Okay, I got the Python code here. So it's got this thing called the session store that you can actually use to grab this stuff. So let's start a shell. Session store. Okay. So here's the module. Gone. Okay, so what I've done is I've loaded up that same session class that we were just looking at in the Django shell. And you can see I'm using normal Django features to talk to it. So here I grabbed a session object, and we've got a couple here. So we could ask for the last one. Here we have a session object. What can we do with that? Well, to begin with, we can get the session data. And this is giving us that same long string that we saw in the database. Now there's this thing called a session store. I dutifully put it in my slides. Let's try to find it. Do we want? Get session store class. Thank you. All right. Okay. So we grab the session store class, and then we can decode the session data. What's it called last? Oh, we call it session. Okay. So we got through, there's a bunch of quite a weird Django rigmarole with the session store, but we've grabbed that session data and we've decoded it, that long string. It's not quite base 64 encoded, but it's pretty close. It contains this data. So you can see that this here, this is a Python dictionary, and it's got 3 fields. It has the auth user ID. It has this backend thing, which doesn't matter. And it has this auth user hash. That's used in case of password changes to log in anyone who was logged in with the old password. But like, this is the main one. You can see that we have an auth user ID here. So we can take this decoded session data. We can get the auth user ID. We can parse that as an integer. We can get from fast app import models. Can do models user objects get ID equals this. Oh. Django. Okay, and so this is all that Django is doing internally. What I've tried to do is I've tried to show you all of this code that's happening just on the command line here. So what we did is we looked at all of the session objects and read them from the database here. Actually, could people in the back see? Ah, my apology. So here's all I did. We first go sessions models yeah. So first I loaded all of the sessions from the database in much the same way as Django.contrib.sessions is the app that does sessions. So then we got its models. It has a model called session, and I got all the objects. So I loaded all of them here. Let's actually get the last one. So we have this single session object. So this is the first, well, that's not the one I wanted. Huh. I wanted the one that starts with HZ. Well, whatever, they're all logged in as background. So I got this session object from Django. I could do it, I suppose what I should really do is I should do session key equals, and then I can copy paste this string that my browser is sending to Django. And that allows me to load a session object. The session object has some session data in it. That's this kind of crazy string. But there is a kind of weird helper in Django that lets us decode it. So we can get this session data equals. So this uses something called a session store, which has a convenient decode function. Okay, so we run that, and now we have this session data. Inside the session data, there's a couple of fields, but the main one is this auth user ID. So now we can get session data, auth user ID. We can parse this as an integer, and we could just load the user object from that ID. And that gives me the Django user object of who's logged in. So these are the steps that Django is going through in order to figure out who are you, specifically when this request comes in, which logged in user does it correspond. And I have to say the session code in here is not super complicated. You can see that this session class is super short, got very little in it. Oh, there's a get decoded method. Huh, I probably should have looked at that. And there's this step in the middle, which is responsible for actually creating the session. This uses a kind of weird Django feature called middleware that basically lets you intercept HTTP requests. But at a high level, you can see all it is doing is it is processing requests and responses. And this process request one is quite short. It says, go to the cookies, get the session ID cookie, and that's your session key. And then that can be used later on to do various things. And specifically here, this request.session equals self.session store is going to do that sequence of steps that I did to load that session object from the database and decode it. Yes.
So is there a built-in way for, getting go to like, the public?
Okay. Yes, is there a way for Django to verify that you actually are this person? Cookies is it, man.
No, I mean, like, cause I think when we were going through it, there was some other information.
Oh, there's not a lot of other information. There's this auth user ID. This backend thing, that's because you could like sub out user authentication for some other backend. You're not gonna see this change. This auth user hash, that is a hash of the password that's just used for password changes. There is another cookie that I'm sending, this CSRF token. You'll just have to trust me that that's not involved here. We'll talk about in a week what that's. Yes,
So this is kind of the inner workings of how it works.
that's right.
If you were to actually be doing this. would
You're not going to be actually doing this. I'll talk about that a little later, but I want you to get a sense of how this works, partly because, I don't know, a lot of people know about cookies in a very vague sense, so it seems of general interest to talk about it. And secondly, I want you to understand how this authentication mechanism works, because what you're getting is very limited. What you know is this is the same person, the same browser that made this previous request. That can tell you something. If you know that this request came from the same person who previously logged in as PavPack, that's good, this person is PavPack. But you haven't checked any real world identities. We haven't verified any email. We don't know anything about this person other than they knew the username password for PavPack. You will see in the real world a lot of unusual situations. You might think one user, one person. Very common for couples to have one email address that give me a face. I'm not saying you do this, but like out in the real world, very common. You got a lot of Ted and Jana 20 whatever at gmail.com.
Does that still happen?
Sure does. Sure does. You also have email addresses that are supposed, I mean, my grandparents have one email address.
But they're old, right?
Old people, oh, sorry. This is a key thing. This is a key thing. When I say in the real world, I mean in the world that old people exist. Okay, this is very true. Yeah, when I say in the real world, I'm including old people. They exist. They sometimes use the internet. And in some lines of business, they're very, very important. Like, has anyone ever wondered why there are so many like physical bank branches when you probably do all your banking online? It is because someone goes to this bank branch. If it's not you, that's someone else. Banks aren't all just like on autopilot, buying billions of dollars of real estate for no reason, right? It could be a Chipotle. There's an economic reason why it's not. It could be. All people don't go to Chipotle. I mean, they probably do, right? Yes.
Do this for passwords?
Can they do this for password? You could put the password in the cookie, but you should not do that. The cookie should be an identity document. The great thing about an identity document is that if you were to look at my driver's license,
Thank you.
here you go. You'll have to give it back to me. I need to drive home. If you were to look at my identity document, you would not be able to duplicate it. So Alan here, please examine the driver's license in detail.
It's very nice.
Thank you. It expired recently, so it hasn't gotten grimy over time. Yes, from examining my driver's license, you cannot duplicate such a driver's license. Now, cookies are not quite like this. You could definitely duplicate this long key string and like punch it in your browser, and then you would be me to whatever server issued that identity document. But passwords are worse because, session IDs, they cycle in and out. They are probably limited time. It is pretty cheap to reassign one. A password is quite more complex. If someone grabs a copy of your password, like first of all, to a first approximation, most people use the same password on every website. This is not good, but that means that someone knowing the password they use on your website also tells them a lot of other passwords, right? Changing passwords is a pain in the butt. Like this is why people use the same password on every website because they don't want to learn a second password. So, in general, it's very cheap for you as a service if you suspect anything weird to delete the session and never think about it again. So for example, a user logs in from a location they didn't log in from before. And your internal system believes that that's kind of risky. You can just delete the session. No one's bothered. They just have to log in again. You can't change the user's password for them. That would be bad. Or like send the user a password reset email, they will probably never read it. So for that reason, this cookie is purely an identity document. It doesn't have any useful information. We can look at how it's generated. So set cookie. Session key. What if there's no session? I'll move it. Oh, yes, this will manufacture a new. Okay, I'm not gonna poke into this too much. The point is, it's just a random alphanumeric. Specifically because if someone observes the session cookie for in some manner, which is doable, then they won't get any useful information.
Well, because you were sorry, because you're able to log in, well, 2 weeks ago, you can still get it now. That seems like a bit of a security issue.
I mean, you don't have to do this, right? Django takes an expiration time of 2 weeks, and it's probably configurable. I don't know about you. To log into my email, I have to use this thing called Duo, and that makes me log in twice a day, and it's very annoying. And I'm sure the IT people think they're doing good security stuff. That's up to you. What exactly you think is risky? I don't know. I think it's reasonable in a lot of cases that are like not super important to just not expire the cookies for a very long time. But that's something that you can probably configure in Django, and certainly if you were writing this. Yes.
So the server and the client pass the full document back and forth, like the session key and the session data and.
The session key, only the session key. So if you look here, what my request contained is the session key. The session data lives on the server side. That's really important. Anything the client tells you, anything the browser tells you could be a lie. I can just like change my cookie. What can they do about it? It's not even HTTP only or secure. So I could literally just do. Okay. Let's go back here. And change it. Is it session _ID? No, it's session. Session ID equals, and I can just change the C to a D. And then, did that do anything? No, it didn't. How's that? Is it HTTP only? Oh, it said, stupid tab. Okay. It's gonna what? I gotta do this tab equals slash. Oh, it is HTTP only. I totally missed that. Okay, no, I can't quite do this. But there's probably a way in my browser to open that up. It's certainly stored on my computer somewhere in a file that I. Yeah, sorry, I missed that this little check mark exists. You can't actually mess with it in JavaScript. So the point is, the session data, that's on the server, that's trusted. The client can't mess with it. The session key, that's not trusted, but there's some kind of cryptography going on, wherein the client cannot easily make a session key that the server recognizes, right? These are long alphanumeric strings, these ones. There's only 4 correct ones. You're very unlikely to guess it. And if the Django people have done a good job, they've done like smart cryptography so that there's like some secret hash that's hard to invert, where it's hard to guess what the next session key will be or what any previous one has been. Yes.
So if I don't know exactly what's stored in session data on the server, but if the server needs to update session data for whatever reason, that's just like the stuff they get from.
That's a database, right? Just like any other one. Yep. I mean, literally, yeah, let's do this. This is gonna be fun. Let's find my session object. And then session, is there a decode? Is there an encode? Awesome. Let's say session data 2 equals session data copy, and then session data 2 auth user ID equals 2. Sure. Oh, I have 2 users. So now I've taken the session data. I'm doing this as an authorized user with access to the server. And now I'm going to encode session data 2. So I get this new random string, and I can say session data equals that, and then I can say session dot save. And now if I look at the decoded session data, it claims that I'm logged in as user ID 2. And if I refresh the page, that's a user ID without access to the admin, so now it refuses me permission. Session ID stayed the same. Here I changed the data that the server stored. This is analogous to, like, I don't know, your criminal record, which the government presumably stores somehow tied to, for example, your driver's license. Or like a number of points you have in your license, right? That's not something you can change, but it's something the government can change because they own that data, store that. Yes.
So in the Django model for sessions, you have the session data, which is your password, your ID.
Yep.
And the session key, which it'll give you a cookie of that you can then use to go back in and.
That's right. So when you visit your website for the first time to log in, Django will make a brand new session key by like taking the current time and a random number from the operating system and turning that into a long random string. And then it will save one copy to its database and hand the other copy to your browser.
And then when you put in like your correct login credentials, it'll update the session data with those.
Correct. Yep. Just like here, we manually updated the session data so as to change what user unlocked it is. All right. So that's how this works internally. And then in Django, this is tied to this Django user. Here I've got a copy of the same user model. And you can see, again, this is a model, much like the ones you've seen. It doesn't start with models.model because there's an abstract base user. In this case, that's not the good stuff. The abstract user is the good stuff. And you can see they have a username, a first and last name, an email, some Booleans, and a date time field. Again, database object, much like a lot of other database objects you've seen. And we can verify this as well by going back to SQLite. There's this auth user group. So we can select star from auth user. And we can see that there is one user. This is the hash of my password, which is the word passpen. You can kind of tell because it has the hash function name up here, pbkdf2 SHA-256. And then a long random string, and this long random, this is the number of iterations, and pbkdf hashes come in 2 pieces. So these are dollars separate. So this is basically my password, and then this is probably when when the user was created or last active or something. Check. Nah, we can't. All right. This is probably something else, and then ID number and username, and this is not 100% sure, and this is probably data. So you can see this same data lives in the database as well. So this whole authentication stuff, one thing I wanted you to keep in mind is this is built on top of the same foundations that you have seen. Cookies, they work much like form submissions. I mean, they're cookies, they're not forms, but otherwise it's data passed back and forth between you and the server. Those sessions are stored in the database and the server can look them up, much like other database objects, and users, those are also just stored in the database as one more kind of database object. Okay? I'm not gonna pause for questions because I think I have a couple more slides. Okay, so how do you actually use this from Django? Pretty conveniently, you get access to this by just calling request.user. Request.user is the current user. Internally, it's using this request.session, which stores the session data, and then looks up the user from the ID stored in the session data. But the easiest way to access this is request.user. And what that's going to return is either a user in your database or this kind of weird dummy anonymous user object. You probably don't want anonymous user, but there's a way to check, I think, is underscore anonymous is going to be true or false. You're going to see details on this in the homework. And then basically you can use request.user to know what user is currently making the request. And you can do any kind of checks you want. You can check if they are in a certain group. You can check if they own a certain object. Basically, that's the point where your security policy comes into play. So at this point where you've determined what user someone is, you've already figured out the first part of the security policy, what kind of users are there, what are the requirements on them, and now you can do authorization. Yes, that's the one. Now you can do authorization and decide, is this user able to perform a certain act? Talk more about that. So in summary, all of this builds on functionality you already know. You've got the request.session using the database and request.user, again, using the database on top of that. Okay, so we will talk a little more about this on Wednesday. One more thing I do want to get to that I skipped earlier. So far, I've described a pretty simple case. Yeah, don't go yet, I know. I got you for 4 more minutes, okay, people? Here I described a pretty simple authentication system where the client issues you a session and then just looks that up in a database. But there's a lot of kind of weird edge cases. You know, there's weird edge cases in the legal system, like changing your name, changing your gender, losing your passport, etc. The Amish. There's also weird edge cases in computer systems. One that you will see a lot is that real world authentication systems at big companies are typically way, way more complicated than simply looking up a user ID. First of all, users will accidentally make multiple accounts, and then you probably need some way to link them. And it might be convenient to have some notion of multiple linked accounts. Secondly, if you're a big company, you probably at some point bought some other company. That other company had its own notion of who users are, and you probably did some kind of horrible thing to mash these together. So you're going to have constellations of different accounts. You will probably in a big company have something like API keys that are only allowed to do certain actions. You might have some kind of sign in with Google functionality. Either people sign into your site with Google, in which case some of what you're looking up lies in Google's database, or people can sign in with your service, which means you're running the other end of that database. And then you might be doing all sorts of complicated things with like single sign-on. So for example, when you log into Canvas, it probably sends you to a University of Utah webpage. So that means Canvas delegates some of its authentication logic to the University of Utah. And there's a complicated interplay of these two systems talking to each other. And the reason this kind of complexity is important to understand is that authentication is the very first thing that any attacker will see, and therefore the one that they would most like to attack, right? So if an attacker can log in as, for example, any user, that might be bad because they can get access to that user's stuff. If they can log in to some kind of administrative user, that's even better, right? Because then they might have access ordinary users don't have. And authentication is the first step to doing any kind of authorization. You're not going to decide, is this user able to perform an action without knowing who the user is. So despite the fact that we've kind of walked through Django's implementation, and hopefully it doesn't seem like total rocket science, I nonetheless am going to advise you not to write an authentication system for 2 reasons. First of all, like log in with a username and password is just, it's probably not the distinguishing feature of your application. right? Innovations in authentication do happen. Has anyone ever had one of those like magic link logins where they email you a link and you click on it and then you're logged in? Yeah, people are nodding their heads. Great. That's an innovation. I think that mostly wasn't happening like 5 years ago, and now it is. But realistically, logging in with username and password is a standard experience. A lot of users expect it. So there's not a lot of value for running your own. And then on the other hand, there's a lot of very subtle ways this could go wrong. So like, for example, one thing you cannot do is compare passwords using like a normal equal sign on strings. There's this weird side channel attack. So you have to do something called a constant time string comparison. A mature, well-tested authentication library will have all of that handled for you. A good reason to use it. Now, again, I wanted to walk you through how it works so you know what you're getting internally, but I wouldn't recommend writing your own. The other thing that I want to mention briefly, we've talked a lot about today about cookies, and I know there's generally a lot of discussion about cookies. People are asking about like the reject cookies banner that the EU makes us put up. Or like, do you remember cookie pop-ups when they only had the words "this site uses cookie" and then you could only click OK? That was also weird. I think people talk a lot about cookies, about tracking. In reality, I think the intuition here is what you expect. Cookies are identity documents for your computer. Governments use identity documents to figure out who you are and to provide you services, and to figure out what you're doing and maybe track you, right? The fact that you are creating identities for your users both gives you a lot of capabilities to help them and also maybe do stuff they don't really want you to do, like track them, figure out what they're doing, tie them to real world identities, exchange advertising identifiers to advertising networks, and so on. The truth is cookies are unfortunately the method we have figured out for issuing identity to users. It'd be very difficult for the web to work without user identities, without the ability to log in. It's that same functionality that makes it possible to track users across websites, figure out what kind of stuff they like, serve them custom ads, and so on. So, you know, yeah, basically the summary is, besides all of the sort of stuff you hear, there is this underlying technical capability. And the technical capability is that the server can ask your browser to remember an identity document and then present it at every next request event. And it's on top of this that we've built all this stuff from user logins to user tracking, advertising, and so on. And now you know how it works. So, okay, we've talked today about authorization, about authentication, and we'll talk on Wednesday about authorization and using this to actually implement our security policies. And I'll see you all then.